Hey everyone. So this is the graphing exercise 1. I guess I'll get myself over here. So this is what you were supposed to have done for, I guess it'd be today. Today is Thursday. And so for the B1 folks, it would be today, Thursday, or today, Friday, if you're watching this tomorrow, which is actually today for you watching it, which is Friday. Anyway. You were supposed to have completed the whole graphing exercise 1. I hope that you were able to do that and it made sense. And I can't remember if I even showed you this in the last video. I don't remember if I did. But this is what your graph should look like. The line here, the line here, oh geez, there we go. It should hit the y-axis up here somewhere. Okay. If, and I've been seeing this a lot, I shouldn't say a lot, a few times I've seen that folks are starting the graph down here at, I guess, 0, and then going up in the first block and putting 25 because that was the first height data point. So 0 and then 25 and then 30 and 35 and 40 and 45 and 50. And that's going to make your line come way down here at the actual origin. If you did that, that means, again, if you said that this is 25 and then 30 and then, oops, oh boy, oh no, that's not the eraser. And then 35 and then 40. Then what you're doing is you're saying that this box right here, the first box is worth 25, and then every box after is worth 5. That doesn't work because that means that this is not 0. That's actually 20. So that's actually 20. And then 15 would be down here, and then 10 would be down here, and then 5, and then 0. So your whole x-axis, I got the hiccups, I'm sorry. Your whole x-axis would have to move down several boxes for that to be correct, which means, see, your 0 or your age axis, for some of you, ended up way up here. And you put your age axis where 20 would actually be. And then you'd have 25, 30, 35, 40. So again, that makes the graph look different than it is. It makes it look like your line comes straight out of the origin, and it doesn't. It intersects the y-axis way up on the y-axis. So you have to make sure that when you set up your graph, you set it up from 0 at the origin, and then you go by the same interval the whole time. You can't change intervals and go like a big jump and then go by 5's a smaller interval. It has to be equal interval the whole way because that will change what the graph looks like for sure. Let me get this thing out of the way. Now, let me get all this stuff out of the way. Oh boy. So hopefully you see what I mean there, and if that wasn't done correctly, you can figure that out and fix it. So the slope I found this spot was right on a grid intersection. This one was halfway between. Because I went by ones here, I kind of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 years across my run, and then 5, 10, 15, 20, 25, 30, and then a half a box. So 30 plus another half a box, and if a box is 5, then a half a box is 2.5, right? Half of 5. So that'd be the 30 plus another 2.5. That'd be a total rise of 32.5. 5, 10, 15, 20, 25, 30, and then 2.5 more. So 32.5 inches would be my rise. And so my rise over my run is my slope. That's around 3.5. And again, it's inches for every year. Inches for every year. So I hope you're seeing that means it's 3.5 inches of height for every year of age. 3.5 inches of height for every year of age. And that's telling us, because we have a straight line graph here with a constant slope, it is a constant ratio, it is a constant proportion, a 3.5 to 1 proportion or ratio that is directly proportional. Okay, that the relationship that we're seeing here between this girl's height and her age is that it is directly proportional, which we had done before, but again, it's been since the first quarter that we've had any of those conversations. So I hope that this part here makes sense. If it didn't before, hopefully it does now. Then we were supposed to answer some other questions here. What is the name of the variable on the y-axis? Well, it's height. And again, I don't remember if I don't know if I did any of this or not before, but if I did, I apologize. You can skip ahead. The next question, oh boy. What is the name of the variable on the x-axis? Well, that's age. And then you're supposed to replace the y and the x with the names, with the corresponding names. So height goes in for y, age goes in for x, and then the m and the b are still just m and the b. We haven't replaced those yet. Okay? So again, we're building the equation of the line as we go through here. Now, it says, look at where the line crosses the y-axis. This is called the y-intercept. What is the value of the height at that point? So for me, on my graph, when I look here, it looks to me like that is about 21 inches. It's pretty close to 20, but it's above it for sure. I don't think it's all the way up to the 2. It might be a little higher than that if it was at the 2. So I think 21 inches is the best estimate. Again, I'm guessing here. You're going to have to guess as well. And so I'm at about 21 inches, which is why I wrote down 21 inches for this answer. That is the value of my y-intercept. Now the next question says, what does that mean? What is that telling us? And some folks in class said, hey, that's the birth height. That is the height of the baby at how much age? 0. Because when you look at the graph, when is the line at the y-axis? The line is at the y-axis when the age is 0. All the way to the left, 0 age, go up, boom, 21 inches. And so they were saying, hey, that means that's how long the baby is. Normally we don't talk about height. Babies don't have height because they don't stand, they lie down. And so we usually don't talk about how tall a baby is, but what their length is. Like the two big stats when somebody has a baby, it's how much did it weigh and how long is it? Length or height. So that's what we said there. Then we were supposed to rewrite the equation, put the m in, and I went ahead and put the b in as well. So we have 3.5 inches for every year in for the slope, which is the m. Hopefully you had somewhere between 3 and 4. If you didn't have somewhere between 3 and 4, then you may have goofed up somewhere. And again, your y-intercept should be so many inches. Now notice there's a unit of measure on this number. There is a unit of measure on this number. Anytime you put a number in an equation, it has to have a unit of measure. Notice up here, I did not just write 21. I wrote 21 inches because I have to tell people what the 21 is. 21 what? Dragons, shoes, fingernails. You have to tell people what the number is. And so I hope you do that. It even says in parentheses, including units of measure. Okay. Now for 8, again, that was already replacing the b. So I did 7 and 8 all in one step here. And then I wrote this down because what I want you to think about is what happens if you put 0 age in here in the equation. If you put 0 years in for age, 0 years, 0 years. Years cancels years. What's 0 times 3.5? Nothing. And so what does that mean? That means our height, the height we get in this calculation, if the age is 0, the height is going to be 21 inches. That's the height. The length of the baby, the height, at age 0, and that's what the equation's telling us. The equation tells us that the y-intercept here is the height when the age is 0. So this little sentence here, okay? The y-intercept is the value of the y variable, value of the height in this case, when the x variable or age is 0. Now think about that. The y-intercept, the plus b out here, the b is the value that you have for the y variable, the height, when the x variable or age is 0. This is going to be how we figure out what does the y-intercept mean for us. It's one thing to figure out what it is. It's another thing to figure out, okay, what is this telling us about this data? And I think at this point, it's pretty clear that it's telling us what the starting height or birth length or height is of the baby based on this information. So we're looking for meaning, okay? Now, the next question is, what is the person's height going to be at age 16? Well, how do you use that equation then to find something out about age 16? Well, you plug 16 years in for where age is. Years cancels years. 16 times 3.5 inches is 56 inches. Plus 21 inches over here for a total of 77 inches. Now, I don't know if you realize this. I mean, it's written right here, but 77 inches is tall. That's 6'5". So this girl at age 16 would be 6'5". So possibly a WNBA, prospect. I don't know. That's pretty tall. So that seems ridiculously tall, in fact. And so if we look back at the graph, I wonder if this line is just going to keep on going up and up and up and up and up and up and up. Well, I hope you can tell that probably won't be the case. That line is not going to continue to go up and up and up and up and up. It's going to eventually what? It's going to eventually level out. In fact, it'll probably level out way before this end part that got drawn on here. It's probably going to level out way before that. In fact, it's probably not going to take too long after age 11 for this thing to stop going up. Okay? Depending on, who it is. Most girls, by the time they're 13, 14 years old, are already at their adult height. They're not going to grow any more height. So that line may look like this. And it's going to curve right over like that. And then maybe this girl will be, 60 inches is 5 feet. And so that would be 5 foot and a half, which would be, or no, that'd be 65 inches. That'd be 5 foot 5 inches. And so this would be maybe 5 foot 3 inches, 5'3". So that would be normal. And it's still going up a little bit, I guess, but it would eventually level out. Okay, so it's not going to stay linear. It's not going to stay directly proportional forever. Like, you don't continue to add 3.5 inches every year for your whole life. That would be a problem. So this is only going to be linear for a short period of time, so many years, and then it's going to level off. I hope that makes sense. Now, one last thing I will say about this one is, that's the wrong one, is that I hope you see there's 2 parts here. The 16 years times the 3.5 inches per year, that tells you how much the girl what? The 16 years times 3.5 inches per year tells you how much the girl grew. That's how much she grew. She grew 56 inches in that 16 years. So is that how tall she was? No, that's how much she grew. Plus, we can't forget, she didn't start from 0. She wasn't 0 inches when she was born. She was 21 inches. So it's how much she grew, like how much she grew per year, times how many years she was doing that, the growth, plus what she started at to get the total height. Does that make sense? So our equation has 2 parts. It has the growth amount plus what she started at to find the height. Now again, notice, we did not put a number in for height. We put a number in for age. We said, hey, I want to know how tall, what is the height of this person at a specific age? So we found a specific point on the graph. And in fact, 11, 12, 13, 14, 15, 16, 16, that would be up about here, if I'm following the line correctly, which would be right about here, which is, let's see, 60, 70. Oh, look at that, right around 77. That's going to be really close to 77 on our graph because the line tells you exactly the same thing as the equation, because the equation is the mathematical representation of the line itself. Okay, so the line and the equation are telling us exactly the same thing. The equation is just how we represent the line mathematically without a graph. So I hope that at least makes some sense. So at this point in class, I posted graphing exercise 2, even though most people seem to do okay with this. I felt like it might be better to do one more round of practice before we get into the actual physics data itself that you're going to collect, and then we'll take a look at. So there is another one of these posted on Classroom, and it looks like this. It is, see below is a table of weekly long runs after returning to running from an injury. And incidentally, this is actually data from my running log from 2014. I had an injury. I had to not run for about 3 months. That was tough. So it took 3 months off to heal up from this injury, and then I started coming back. And so these are the length of the long run, the run that I would do at the end of the week, for each of these weeks. Okay. Now I tell you here which one is the manipulative and which one is the responsive. You, I hope, remember at this point which one goes on which axis. If not, you're going to have to watch the previous video because I tell you there. Remember, M comes before R in the alphabet, and X comes before Y. All right. And the distance that I ran depends on which week I was in for the running. Okay. So you will make that graph, and then you will answer all those questions, and then I will have another video to post on the next time we have class, which will be Monday for the B1 or Tuesday for the B2, and then I will show you, how all that was supposed to work. But you will need to complete this, upload a picture of it on Classroom for the due date, which again will be Monday for B1, Tuesday for B2. But this is exercise 2, the last practice one that we'll do, and then we'll get into actually collecting some of our own data and doing this like for real with real physics stuff, not running stuff and babies and height and stuff. Everybody got that? Hope you got that. And then, yeah, we'll hopefully get this squared away. I think that's it. If you have any questions, though, feel free to shoot me an email, comment, or something on the assignment if you have any issues or questions. And I will hopefully see you soon. Stay safe out there.